So now, how do we actually solve these inequalities? Well, again, these are the manipulations we can do. You can simplify either side, or both sides if you want. You can add or subtract the same thing to both sides. Let me just cross out something. This is not really going to be too much of an issue for us. Okay. But when you multiply or divide, you have to be extra careful. I mean, yeah, you can only multiply or divide by something non-zero, but there's also something else you have to watch out for. If you multiply or divide by something negative, you have to turn the inequality around. You have to flip it. So for instance, this inequality would become this inequality when you turn it around. And when you have this inequality, when you turn it around, right, you're going to have this. You know, you're flipping it. It faces the other direction. Same thing if you had, if you did not have strict inequality. So in other words, if you had this would become this, and likewise this would become this. So basically, you flip the inequality, it faces the other way. You have to do that when you multiply or divide by something negative. Now, you might be thinking, why is that? Well, let me show you by example what happens if you don't do that. For instance, if we have this inequality, 1 less than 2, right? Well, this is true always, right? This is always true because we know 1 is less than 2. If I multiply both sides by -1 and I don't flip the inequality, well, then we're saying -1 is less than -2. That's not true, though, right? -1 is not less than -2. -1 is bigger than -2. So we did not flip the equality symbol, though. So we have something that's false now. Now, first we had something that was true, and now we have something that's false. And if you want to throw in variables, let's consider this. If you have x bigger than x plus 2, for any number x, this is going to be false. Any number x. But if I multiply both sides by -1, right? And again, I did not flip the inequality. Then we have -x is greater than -x minus 2. Well, maybe it might be hard to see it now, but it turns out this is always true. So from false to true. So that's what you have to turn the inequality around. When you multiply or divide by a negative, by a positive, you don't have to. Actually, no, by a positive, you're not supposed to. A negative, you do. So that's what I'm saying here. Okay, that was fun. So let's do an example. Let's suppose we want to solve and graph this inequality. Well, as you can see, we really can't simplify either side any further. So to solve this, we want to get x all alone, just like with an equation. Right? Just like with an equation, you want to somehow get x all alone, preferably on the left side. And that's what I'm doing here. You don't have to do the exact same steps in the exact same order that I'm doing. But what am I doing here? I'm subtracting 1 from each side, right? So the 1s cancel, and on the left you just have 5x. On the right side, though, you have 7x minus 4. Excuse me. So now we have 5x is less than 7x minus 4. Now what I did next was I subtracted 7x from both sides. So now the 7x here is gone. We're left with negative 2x though. So we have negative 2x is less than negative 4. But again, just like with equations, we don't want negative 2x, we want x. So what do? We divide by negative a half. Doing so, as you can see, the negative 2 and negative 2 cancel. We're left with x. We flip the inequality so it's facing the other way. And negative 4 over negative 2 is 2. So in this case, our solution set, as you can see, is all x greater than 2. And that's graphing it. Our solution set, again, is the interval from 2 to infinity. And this is a graph. Graphing is not really something I'm going to have you do on exam quizzes, but I felt better going through it. So this is what we have here, right? Again, we're not including 2. It's strict inequality. We have an open circle there. Pointing to the right, okay, infinity. Because it keeps on going to the right. Every number to the right of 2 is a solution, and we want to include that. All right, that's good. That's one example. Let's try another one. So now we're going to handle this one. Okay, so again, here notice you could simplify a bit, right? You can simplify the left side. Excuse me, and you can simplify the right side. So for the left side, that's just this. We have negative 5x plus 10. You know, we're distributing. Let me try that. As you can see. And for the other side, same idea, right? We distribute. Right? And then we get 3x plus 3 plus 10, which is 3x plus 13. So we've simplified each side. So this inequality is what we want to solve. Okay, that's good. Well, let's do that. This one I want everyone to try. So let me do this. Let me just let me just pause the recording now.